Section 9.4a is about factoring trinomials again, but this time our trinomials are going to be a little different. They're going to have a number other than 1 in front of the x squared, and that's going to make our diamond portion a little bit more difficult, but other than that, we're going to factor these trinomials the same way we have in the past. Well, let's start with this example. As we make our diamond, one of the things that I've been talking about is you multiply the first number times the last number. Now that's been real easy so far because this first number has always been a 1. Now, however, it's a 7, and when you multiply by 3, you get 21. So we want two factors of 21 that add to give us the middle coefficient, which is 22. Well, I'm going to list the factors of 21, 1 and 21, and 3 and 7. Which one of those can I use by adding or subtracting that gives me a 22? And obviously it's 1 and 21. So I'm going to rewrite my trinomial 7x squared in the front plus 3 in the back, and the middle term is going to be plus 1x and then plus 21x. So far this is almost identical to what we were doing before, and it is, except this number in front isn't a 1, and so now I got to figure out what the GCF here. It's an x, leaving a 7x plus 1 behind. Now I want a 7x plus 1 to be left, so I'll take out a 3, and that will leave a 7x plus 1, which will then factor into 7x plus 1 times what's left, in this case x plus 3. So if you notice, all the steps are identical to factoring any trinomial. It's just now the diamond over here is going to be harder. This one was actually pretty easy to start off with, but you can get some pretty big and complicated numbers over here. We're going to factor this trinomial now, making the diamond multiply the front coefficient by the last term. 5 times 10 is 50, and the middle term is 27, so that goes on the bottom of the diamond. So let me list all the factors of 50, 1 and 50, 2 and 25, 5 and 10. That's it. Now I got to find two of these factors that will give me a 27. Well, it looks like 2 plus 25 will work. So now I'm going to rewrite my trinomial. 5x squared in the front, plus 10 in the back, plus 2x in the middle, and plus 25x in the middle. So now we'll group. Take out an x, looks like 5x plus 2. So I'll take a 2 out over here. Again, looks like 5x plus 2. So take out the 5x plus 2, and I'm left with an x plus 2. Here we'll factor this trinomial with the diamond. Multiply the 10 by the 28. 280 on the top, and a negative 43 on the bottom. Now, listing all the factors of 280 could be a difficult thing to do. One thing you might want to do is just take a calculator and start dividing 280 by bunches of numbers. Start by 1, by 2, 2 times 140, see if 280 divides by 3, 4, 5, and so on. So here you see the list of all the factors of 280. This could take a while for this number because you need to divide it by lots of things and try to find all the factors. Now you want to go and try to find any two factors that we can combine here that gives us a sum of negative 43. Now in the list I noticed that 8 and 35 equal 43, but I want a negative 43. So if I use negative 8 and negative 35, those will add to give me a negative 43. The question is, do they multiply to give me a positive 280? And the answer is yes. So that's how I find my two factors. And now I can continue. So the two factors over here that go in the middle are minus 8x and minus 35x. Now we'll factor by grouping. Be sure to include the negative sign with the 35. Looks like I take out a 2x, leaving a 5x minus 4. Over here I'd like a 5x, but it's negative 35, so I take a negative 7 out, leaving me the 5x minus 4 that I want. And then take that out, 2x minus 7. So this one had the same exact steps, but it was a lot harder to do the diamond here and to find these two factors. And that's the one step that might be more difficult when you have a coefficient in front of the x squared that isn't a 1. In this trinomial, you should notice something that might save us a lot of work at the end. If you look at each one of these terms, you might notice that they all have a common factor, a GCF if you will. They all have a factor of 3. So if I were to take that factor of 3 out, I'd be left with x squared plus 8x plus 15. Now that's important because once I take that 3 out, all I really have to factor then is this trinomial inside. And that's a much easier one to factor because the top of the diamond is going to be 15 and the bottom is going to be 8. And it's a lot easier to find two factors of 15 that add to be 8 than it is to find two factors of whatever 3 times 45 is that add to be 24. In this case, it'll be 3 and 5. So I'm going to rewrite my trinomial like I normally would, but I'm going to be careful that I don't forget about this 3 here in the front. And I'm going to circle it here in red just to remind you that we've got to talk about that at the end. So rewriting the trinomial with a plus 3x and a plus 5x. Factor by grouping, take out an x, take out a positive 5. So you end up with factors of x plus 3 and x plus 5. Now back to this 3 that I pulled out at the beginning, you've got to include that in your answer because your answer includes not only these two binomial factors, but it includes this number factor out in the front. So we really factored twice here. We factored once by taking out a GCF of 3, and we factored a second time by using the diamond here to factor this into two binomial factors. Our last example here is a trinomial that we will factor by multiplying the 2 times the negative 2 to get a negative 4, and then in the bottom we're going to get a 5. Listing the factors of 4, I get 1 and 4 and 2 and 2. Well, the only ones that can possibly work here are 1 and 4 that give me a 5. But you might notice there's a problem. 1 plus 4 is 5, but 1 times 4 isn't negative 4. And if I make one of them negative, I'm not going to be able to get a 5 for the sum. So if you think about it, even though 1 and 4 looks like it should work, it actually doesn't. So there are no factors at all that I can multiply to get negative 4 and add to get 5. So this trinomial is a special trinomial. We call it a prime polynomial. It's a polynomial that cannot be written as a product of two polynomials. We can't do it. Now this little added thing on the end with integral coefficients, that means that really you could write this as a product of two polynomials. It's just the coefficients wouldn't be integers, but we're not going to worry about that right now. For our purposes, we're going to understand that we cannot factor this polynomial because it doesn't have the correct factors to do it. If you ever have a polynomial that won't factor this way, all you have to do is write prime.